Hello guys, this is Vivek Verma and welcome back to 100 Days of DSA Challenge. Today is day 3 of our DSA Challenge and we have this problem, merge intervals. It's a medium problem on lead code and let's dive into it and let's understand what the problem asks for and how are we going to find out the answer. Okay, so it says given an array of intervals where intervals of at ith index say it has a starting index and an index. Merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay, understood. Okay, take it. Let's continue. So what it says, suppose it is saying that there's an array which contains intervals and has the starting index and the end index, and it has the intervals which are overlapping. So what we need to find out the non-overlapping intervals only, and if there are intervals which are overlapping, then we have to combine those and give the output of only the non-overlapping intervals. Just like in this example, we have interval 1 to 3 and 2 to 6. Here 2 comes in, like 2 is smaller than 3, so 2 is overlapping with this 3, and we have 6, so it becomes 1 to 6, just like how you can see here. And then 8 to 10, 8 to 10 is overlapping with none other, like 8 is greater than 6, then it becomes a new interval, 8 to 10. And next we have 15, 15 is also smaller than this, sorry, greater than this, then we need to count it as a new interval also. And let's understand something, like let's suppose, if I can just open schedule. Okay, so if I can just share, like let's suppose let's suppose that there is an interval. Let's suppose there is an interval, uh, 2 to 6. Then there is an interval, uh, 3 to 8. And there is an interval, 9 to 12. And then there is an interval, 11 to 15. Okay. So what it says is we will start from here. Okay. We will start from here. We'll start from here, and we'll say that okay, we take this 2 as our starting index. Okay. Starting interval position. Then we move forward, and we have this 6 as the end. This is the start interval, this is the end interval of an interval. Okay. And let's continue with the second one. Okay. We see this 3. This 3 is smaller than 6. Here it's smaller than 6. So what we can do is we know it from here that 3 would come between this interval. Okay. So what we will do is we will change this 6 to with the value of the next greater or larger interval ending. Okay. So we get this 8. So what we will do, we will remove this 6 and add 8 instead of it. So the new interval will be 2 to 8. Okay. 2 to 8. Now we'll move forward. We'll move forward with this. Okay. Here this 9, here this 9 is greater than this 8. This 9 is greater than 8. It means this interval can never be in this interval, can never be a part of this interval. It means this interval is non-overlapping with any of the other intervals. So this interval will count as a new interval, and we'll say that okay, we got 9 to 12 as a new interval. And now we'll move forward with the last interval we have in the interval select, and we'll say that okay, this 11, we'll take this 11 and see if it is smaller or greater than this last end of the last interval which we had. So we have 11 as smaller than this 12. So it means this interval, this one belongs to the interval itself. Then it means after that we have the larger one. Okay, larger ending. So we will replace this with the larger ending. So we get a new interval, 9 to 15, and this is also a non-overlapping interval. This is also a non-overlapping interval. So now we have these two intervals, which we can return as answers. Okay, so the answer array will contain these 2 to 8, and then from 9 to 15. And also to get to this, what we need to do is we need to sort the interval array first. Okay, such that such that whatever we do when we proceed further, so we would not have to think that there can be a number which is greater than this interval earlier than the interval. So it means we first need to sort the whole interval array such that we get the starting index sorted and then the end index sorted, so that we can move forward with this approach which we know. And this is a brute force approach. Okay, and we will get to the optimized approach also, but first this brute force approach. So let's start with writing the code. Okay, so what we can do is n equals to uh, intervals dot size. So we get the size of the array, and then we sort this array intervals dot begin intervals so and as I am just showing this, but I have already written the code. See here, as you can see, this is the brute force approach. Okay, like we sort the array, and then we initialize a new array, answer array, so that we can store the new intervals which we have formed in this new array and then return it. So and then we start with the index 0 and run a loop until n, and then increment index. So we take the start index at the first start index of an interval in the intervals array. So this is the ith of 0 of ith interval, and as this, and then we check if the array is if the array is not empty and is smaller than and is smaller than what we had in the array before. Okay, like the end. This is the end which we are on, like what we talk about. See, if you're talking about this, so if we have the end of the end of this is smaller than this array is before end. Okay, sorry, is smaller than the array, the end interval which we had in the answer array. So what we will do, we'll continue. Okay, because it is smaller. If it is smaller, see, I said here, as I said, uh, yes. So we will move forward. We will continue, and then we'll run another loop which goes from j, and j is initialized at I plus one, and it will go from uh, I plus one to up to the size of the array, interval array. And what we will do is, if we find out that the next starting index of an interval is smaller than the end of the last interval, which we pushed into the answer array. See, if it was smaller than this, then what we'll do, we will update the end to the max of end and the interval which we have now, intervals and. Okay, we will update the new end to be to hold the value of maximum between the end which we had earlier and the new end which we got from the new interval, and otherwise we'll break. And then we push this starting index and end index interval into the answer array, and then we'll return. And for the optimized approach, what we will do, we simply do not need to run two loops. Okay, we will just run a single loop, and first we check if the answer array is empty, or the starting index of the uh, starting interval of the ith index interval is smaller than no is greater than the last intervals and or ending integer. Then what we can do is we can push back that interval into the answer array. Otherwise we will update the end of the interval in the answer array, and then we will return the answer array. And that's how I can show that I ran these last optimized approach. I got 4 ms runtime, and this is what I got. Like I just did it 20 minutes ago. So yeah, make sure to follow so that you can be with me in this journey of completing 100 days DSA challenge. Thank you.